Today we're taking a look at one of the most awesome sights in our solar system, the rings of Saturn. Saturn is a gas giant, a planet made mostly of gas. It's the sixth planet from the Sun. But did you know that those rings are disappearing? Saturn's rings are huge. They're made up of billions of pieces of ice and rock. Some of these pieces are as small as dust particles. Others are as big as houses. The rings are so big that you could fit all of the planets in our solar system between them. But as we gaze upon this celestial marvel, a perplexing question arises. Why are Saturn's rings vanishing? For centuries, astronomers have been captivated by the ethereal beauty of Saturn's rings. These icy structures, a celestial ballet of countless particles, have inspired awe and wonder in equal measure. Yet recent observations have revealed a startling truth. Saturn's rings are slowly but surely fading away. Like tears in the rain, these cosmic rings are gradually disappearing, leaving scientists baffled and eager to unravel the mysteries behind their demise. What forces are at play, slowly stripping Saturn of its most iconic feature? Join us on this cosmic adventure as we delve into the heart of this celestial enigma, exploring the scientific observations, the leading theories, and the latest discoveries that shed light on this captivating phenomenon. For centuries, telescopes have allowed us to marvel at Saturn's rings from afar. But in recent decades, we've gotten a much closer look. Space probes like Voyager and Cassini have given us breathtaking views of these rings, revealing their intricate structure and composition. Scientists have been studying data from these space probes, and what they've found is both fascinating and a bit alarming. The data shows us that the rings are becoming thinner. This thinning is happening at a faster rate than anyone had predicted. It's like watching an hourglass slowly drain, knowing that eventually the sand will run out. But how do we know that the rings are thinning? Scientists have a few ways of measuring this. One way is by observing how light from distant stars passes through the rings. The amount of light that gets through tells us how dense the rings are. And the data is clear. The rings are getting less dense over time. So if Saturn's rings are disappearing, where are they going? The answer lies in a phenomenon scientists call ring rain. The rings are constantly being bombarded by sunlight and charged particles from the sun. This bombardment, along with the gravitational pull of Saturn itself, creates an electric charge in the ring particles. This charge causes the particles to be pulled in towards Saturn by its magnetic field. As these particles spiral down towards the planet, they interact with Saturn's atmosphere, creating a sort of ring rain. This ring rain is essentially pulling the ring material down onto Saturn. It's like a slow and steady drizzle that's been going on for millions, maybe even billions of years. And while this ring rain might sound gentle, it's having a dramatic effect on Saturn's rings. Scientists estimate that the rings are losing material at a rate of several Olympic-sized swimming pools every hour. That's a lot of ice and rock falling onto the planet. Now you might be thinking, if the rings are losing so much material, why are they still there at all? The answer likely lies in the age of the rings themselves. Scientists aren't entirely sure how old Saturn's rings are. Some theories suggest they formed billions of years ago, alongside Saturn itself. Others propose that they are much younger, perhaps only a few 100 million years old. If the rings are ancient, then their current rate of disappearance suggests they could vanish completely within the next 100 million years or so. That might seem like a long time, but in cosmic terms, it's just a blink of an eye. This potential vanishing act gives us a unique opportunity. By studying the rate at which the rings are disappearing, scientists can work in reverse to try and determine their age. It's like using a cosmic clock with the rings' disappearance marking the passage of time. So we know the rings are raining down on Saturn. But what's causing this ring rain in the first place? This is where things get really interesting. One theory suggests that a long-lost moon of Saturn might hold the answer. Imagine, if you will, a moon orbiting Saturn, much closer than any of its current moons. This hypothetical moon, which scientists have dubbed chrysalis, would have been made mostly of ice, just like Saturn's rings. Now picture this. Over millions of years, chrysalis's orbit brought it too close to Saturn. The planet's immense gravity started to pull on the moon, stretching it and tearing it apart. Eventually, chrysalis would have been ripped to shreds, its icy remnants scattered into orbit around Saturn. These remnants over time would have spread out and collided, eventually forming the magnificent rings we see today. Even if chrysalis did give birth to Saturn's rings, its influence likely didn't end with its destruction. The gravitational forces at play in Saturn's system are complex and ever-changing. The The planet's many moons, each with its own gravitational pull, tug and pull on the ring particles, creating a sort of cosmic dance. This gravitational interplay can have a profound effect on the ring's structure and evolution. For example, some moons, known as shepherd moons, act like cosmic herders, their gravity keeping the ring particles confined in narrow bands. Without these shepherd moons, the rings would likely spread out and dissipate much more quickly. But even with these shepherds, the rings are not immune to the relentless pull of Saturn's gravity. Over time, this gravitational pull can cause the inner edges of the rings to spiral inwards, eventually falling into the planet's atmosphere. Let's take a closer look at these shepherd moons because they play a crucial role in the story of Saturn's rings. These small moons, some no bigger than a city, orbit Saturn within or near the edges of the rings. Their gravity acts like an invisible fence, keeping the ring particles in line. Imagine a shepherd herding sheep, keeping them from straying too far from the flock. That's essentially what these moons are doing, but on a cosmic scale. Take, for instance, the shepherd moons Prometheus and Pandora. These two tiny moons orbit Saturn on either side of the F ring, one of Saturn's outermost rings. Prometheus on the inside track moves slightly faster than the ring particles. As it passes by, its gravity pulls on the particles, giving them a little boost in speed. Pandora on the outside track moves a bit slower than the ring particles. Its gravity gently tugs on the particles, slowing them down. This constant push and pull, this cosmic dance between the shepherd moons and the ring particles, helps to keep the F ring narrow and well-defined. But the shepherd moons aren't the only players in this cosmic balancing act. Saturn's magnetic field also plays a role in shaping and influencing the rings. This magnetic field, generated deep within the planet's core, extends far out into space, enveloping the rings in a sort of magnetic cocoon. Charged particles from the sun, streaming through space at high speeds, get trapped by this magnetic field. These trapped particles then interact with the icy ring particles, creating a complex and dynamic environment. Some scientists believe that these interactions between the magnetic field, the charged particles, and the ring particles could be contributing to the ring rain. The exact mechanisms are still being studied, but it's clear that Saturn's magnetic field is a force to be reckoned with. For years, the idea of ring rain was just a theory, a plausible explanation for the disappearing rings, but hard to prove from millions of miles away. However, thanks to the Cassini spacecraft, we've been able to observe this cosmic drizzle up close and personal. During its final orbits, Cassini flew through the gap between Saturn and its rings, a daring maneuver that provided a treasure trove of data. Instruments on board Cassini detected a surprising abundance of organic molecules, water ice, and even tiny grains of rock raining down on Saturn's atmosphere. This ring rain, as it turns out, is more like a constant downpour with tons of material being deposited onto Saturn every second. The findings from Cassini confirmed what scientists had long suspected. Saturn's rings are not a permanent fixture. They're slowly but surely fading away, like a beautiful sunset that eventually gives way to night. This discovery was a major breakthrough, providing concrete evidence to support the theories about the ring's demise. But it also raised even more questions. How long has this ring rain been going on? And how much longer will Saturn's rings last? To answer these questions, scientists have turned to a variety of methods, piecing together clues like cosmic detectives. One approach involves studying the composition of Saturn's upper atmosphere. By analyzing the light passing through this region, scientists can identify the chemical fingerprints of the ring material falling into it. These observations have revealed that the ring rain is, in fact, altering the composition of Saturn's atmosphere, albeit subtly. Another line of investigation focuses on the age of the rings themselves. While we don't have a precise birth certificate for these celestial structures, scientists can estimate their age based on a number of factors. One method involves studying the ring's mass and the rate at which they're losing material. By working backward, scientists can get a rough idea of how long the rings have been around. Current estimates suggest that the rings are likely hundreds of millions of years old, but probably not billions. So what does the future hold for Saturn's rings? Based on current estimates, it's likely that the rings will continue to rain down on Saturn for millions of years to come. However, the rate of this cosmic downpour could vary over time. Interactions with Saturn's moons, changes in the solar wind, and other factors could all influence the rate at which the rings are losing material. It's even possible, though unlikely, that some unforeseen event could accelerate the process, causing the rings to disappear much more quickly. Or perhaps Some as-yet undiscovered mechanism is replenishing the rings, albeit at a slower rate than they're losing material. The truth is, we don't know for sure what the future holds for Saturn's rings. But one thing's for certain, they won't be around forever. As we continue to explore our celestial neighborhood, we're bound to uncover even more mysteries, challenge our assumptions, and gain a deeper appreciation for the wonders of the cosmos. As we conclude our exploration of Saturn's vanishing rings, we're left with a sense of awe and wonder, but also a profound realization. The universe is full of mysteries, and the more we learn, the more we realize we don't know. Saturn's rings, once thought to be eternal and unchanging, are now revealed to be ephemeral, slowly fading away like a cosmic whisper. This discovery underscores the dynamic nature of our solar system, a place where celestial objects are born, evolve, and eventually fade away, their stories etched in the fabric of space and time. The ring rain, the shepherd moons, the intricate interplay of gravitational forces. These are just a few pieces of the puzzle, glimpses into the complex processes that shape our universe. And as we continue to explore, we're bound to uncover even more questions, pushing the boundaries of our knowledge and challenging our understanding of the cosmos. So what do you think about this cosmic mystery? Share your thoughts and theories in the comments below. And if you enjoyed this journey through space, don't forget to like and subscribe to Time Pilgrimage for more mind-blowing explorations of the universe. As always, keep looking up and keep those questions coming.